Hello, everybody. So for today's brain starter, two more questions finding the zeros. By now, you guys should be pros at this. So go ahead, use the method that it requires to find the zeros, and I'll go over it in just a second. All right, so this first one here is saying you have to solve by the square root method. So we have to undo everything that's happening to w. So the last thing that's happening to w here is that it's being times by 9. So we're going to start by dividing both sides by 9. When we do that, this cancels out, and now we have w squared plus 1 is equal to 1. Okay, the next thing that's happening to w is that 1 is being added, so we're going to subtract 1 from both sides. So now we have w squared is equal to 0. And the last thing we're going to do is take the square root of both sides to undo the square. And the square root of 0 is, of course, 0. Not plus or minus 0. There is no positive or negative 0, just 0. So w is equal to 0. Okay, over here we're going to use completing the square. So you might wonder, what about this problem? Why is completing the square going to be the best method? Well, it's already set up for us to do completing the square. Okay, normally we would say we have to set it equal to 0 and then move our c term over, but our c term is already by itself on this side. So we can go ahead and we can use completing the square from here. So the next step, I'm going to take the b term, cut it in half and square it. So 8 cut in half is 4, and 4 squared is 16. So I'm going to add 16 to both sides of my equation. So now I've got w squared plus 8x plus 16 is equal to 47. Okay, now I'm going to factor my trinomial on the left-hand side, and I'm going to rewrite it as a squared binomial. So factored and rewritten as a squared binomial would be m plus 4 squared is equal to 47. Okay. Now I'm going to take the square root of both sides to undo that square. That's going to cancel out over here, and we have m plus 4 is equal to plus or minus the square root of 47. The square root of 47, it cannot be simplified any further. Remember, we have these perfect square numbers. 4, 9, 16, 25, 36, and I can stop there. None of these numbers divide evenly into 47, so we can't simplify radical 47, so it stays radical 47. The last thing we need to do is subtract the 4 from both sides. So m is going to be equal to plus or minus the square root of 47 minus 4. So if at this point you're really not comfortable solving these two problems, you need to go back and review some of the notes and some of the videos on the different methods. It's really, at this point, you should be pretty comfortable using each of the methods to find the zeros. Today's learning target is I can apply my knowledge of finding the zeros of quadratics to real-world problems. So earlier in this unit, we looked at word problems that required us to do a couple things. They required us to find the vertex. They required us to find the axis of symmetry. And we also answered word problems when looking at graphs of quadratics. Today we're going to look at a second set of word problems that requires us to find the zeros to get the answer. So everything we're going to be doing today is going to be based on finding the zeros. Come our test next week, you need to know what types of word problems are asking for what. So you need to be able to recognize when you need to find the vertex, when you need to find the axis of symmetry, or when you need to find the zeros. So you may need to go back and review the previous word problem lesson that we did. Okay, the first question here is are word problems that are asking you to find an x value. Okay, so it's word problems that are asking for the time it takes for an object to hit the ground or the horizontal distance an object travels. So let's look at this question we have here. An acorn drops from a tree branch. The function negative 16t squared plus 20 gives the height of the acorn after t seconds. At what time does the acorn hit the ground? So if we're imagining, here's a graph, and we have a tree. Here's my beautiful tree. And an acorn is going to fall from this tree. And it's going to fall, 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 and it's going to hit the ground somewhere. What we're looking for is what this value is on the x-axis. What we're looking for is the greater of the zeros. And when we do word problems, we're only looking for the higher zero. The bigger zero is the one that we're looking for. We're not looking for we don't care about this part of the parabola because that's going into the negative. Acorns can't fall into a negative value. Okay, they can only fall a positive distance. It can't go in net. It can go backwards. It could go this way, but it's still a positive distance that it's falling. An acorn can't fall a negative value. That doesn't make sense. So I'm going to erase this picture here so I have room to do the problem. And again, what we're looking for is to find the greater of the two zeros. So the equation it's asking us to work with is negative 16t squared plus 20. So I like factoring, so I'm going to use factoring to find the zeros here. So right away I could see that there's a GCF, and there's a GCF of 4. So I can pull out 4, and then in parentheses I would have negative 4t squared plus 5. Okay? So now I'm going to take each of my factored pieces, and I'm going to set them equal to 0. I'm going to solve. Well, 4 equaling 0, that doesn't make sense, so we can disregard that one. So the next one we're going to have here is negative 4t squared plus 5 is equal to 0. So I'm going to subtract 5 from both sides. We've got negative 4t squared, negative 4t squared equals negative 5. I'm going to divide by negative 4. Divide by negative 4. So now I've got t squared is equal to 5/4, or I'm going to write this as a decimal. So that would be 1.25. Now I'm going to take the square root of both sides. And again, we only care about the positive values here. So our final answer would be t is equal to the square root of 1.25. We don't care about the negative one. So whatever that square root of 1.25 is, that's how many seconds it'll take for that acorn to hit the ground. Okay. Now another type of word problem that's asking us to find the zeros looks a little bit more like problems we did earlier in the year. And these are ones that are asking us to find the dimensions of a rectangle. So let's read this problem and I'll model. You are knitting a blanket. You want the area of the blanket to be 24 feet squared. You want the length of the blanket to be 2 feet longer than the width. What should the dimensions of the blanket be? Well, the first thing we're going to do is make a let statement. This sounds a lot like the problems we were doing in the beginning of the year when we had to make let statements. We need to recognize the length and the width. So it says you want the length of the blanket to be 2 feet longer than the width. Okay, so if we say let x equal the width, we could say then let x plus 2 equal the length. And when we get the area of this, the area is going to equal 24. So in other words, width times length is going to equal 24. Well, from here we need to simplify and we need to solve. And we're going to use the square root method here. So I'm going to distribute my x. That would be x squared plus 2x is equal to 24. Okay, we're actually not going to use the square root method here. I misspoke. So now we have a pretty comfortable polynomial to work with. Let's move everything over to the same side so that we can either factor it or use the quadratic formula or difference of a perfect square, however we want to do it. So now we have x squared plus 2x minus 24 is equal to 0. Now I'm going to factor this one, because like I said, I like to factor. So I'm looking for two numbers that add to 2 but multiply to negative 24. Well, that would be positive 6 and negative 4. Okay, then I'm going to set each of my pieces equal to 0, and I'm going to solve. So I got x plus 6 equals 0, x minus 4 equals 0. Over here, we'd subtract a 6 from both sides, and x would equal negative 6. And over here, we'd add a 4 to both sides, and x would equal 4. And again, we only care about the greater of the two zeros in problems like this. So this is not part of our solution, even though it's a 0. The dimensions of the blanket should be 4 and 6. Okay, 4 and 6 are going to be our dimensions here, because if x is equal to 4, 4 plus 2 is 6. All right, so why don't you guys go ahead and practice two problems here and see if you could solve. All right, this first one here, you're building a rectangular deck. The area of the deck needs to be 250 feet squared. You want the length of the deck to be 5 feet longer than twice the width. So if we say let x equal the width, the length is 5 feet longer than twice the width. So 5 feet longer than twice the width would be this. And the area of this deck should be 250. So when we multiply these two values, it should equal 250. So from here, we're going to solve. So that would be 2x squared plus 5x equals 250. Let's move everything to one side. So now we have 2x squared plus 5x minus 250 is equal to 0. And what method do I think would be the best to use for this one? Well, I think the quadratic formula would be the best. We have some big numbers here. Doesn't really look factorable. We'd have to use the slide method with big numbers. It'd be difficult. So let's use the quadratic formula. So that would be -5 plus or minus the square root of 5 squared minus 4 times 2 times -250, all divided by 2a, which would be 4. So first I'm going to figure out the discriminant. So when I plug that into the calculator, I get a big number, 2,025. So we have -5 plus the square root of 2,025 divided by 4. And we have -5 minus the square root of 2,025 divided by 4. Well, lucky for us, 2,025 is actually a perfect square. This would be a pain in the butt to simplify. The square root of 2,025 is 45. So we really have -5 plus 45 divided by 4. And we have -5 minus 45 divided by 4. Well, -5 plus 45 is 40, and 40 divided by 4 is 10. And -5 minus 45 is -50. And -50 divided by 4 is -12.5. So again, we only care about the greater of the two values. So the answer to this question is 10. The width would be 10. And the length, when you plug 10 in here, 2 times 10 is 20, plus 5 is 25. So 10 and 25 should be the dimensions of this deck. Okay, let me make some room over here to do the other problem. So a ball is dropped from the roof of a building. The height is, so again, if we drew a picture here, here's the building, here's the roof. A ball is dropped. Maybe it's going to look something like that. Okay, and it's given by this equation: -16t squared plus 72. At what time will the ball hit the ground? So what is going to be that value here? So we need to find the greater of the two zeros. So we have -16t squared plus 72 is equal to 0. Well, let's see what I can factor out here. So the biggest common factor of 72 and 16 is going to be 8. So I can pull out the 8, and we have -2t squared plus 9. And remember, this one we can forget about because 8 equals 0 makes no sense. And from here we can solve. -2t squared plus 9 equals 0. I'm going to subtract the 9 from either side. We have -2t squared equals -9. And divide by -2. So now we've got t squared equals 4.5. And we're going to take the square root of both sides. And again, we only care about the positive one. So we can just say positive radical 4.5, or t equals the square root of 4.5. So again, make sure you're going back and not only comfortable with the word problems here, but you're also comfortable with the word problems from the previous lesson we did the week before last. You'll have to be able to answer both of these word problems when we take our test next week. My understanding is that there's no school tomorrow. Tomorrow is a professional development day for teachers. And then on Friday, you're going to have a graded performance task. It's really just a work time. Don't let the name scare you. But it's all word problems, and it's going to be word problems that require you to find the zeros. And that'll be due Monday. So make sure you reach out if you have any questions, guys. Take care.